So children, now let us try to understand in detail regarding the differences between acceleration due to gravity, that is indicated with the letter small g, universal gravitational constant indicated with the letter capital G. So first of all, let us try to focus on this acceleration due to gravity. What is meant by acceleration due to gravity? The acceleration produced in a body. What type of body? On a freely falling body. The acceleration produced in a freely falling body due to the Earth's gravitational pull is called as your acceleration due to gravity. What is that? The acceleration produced in a freely falling body due to gravitational pull of Earth is called as acceleration due to gravity, and its value is about 9.8 meter per second square on the surface of the Earth. As we move higher above the surface of the Earth or we move deep inside the surface of the Earth, its value decreases. If we move away from the surface of the Earth or if we move deep inside the surface of the Earth, both cases the value of G decreases. But at the center of the Earth, the value of acceleration due to gravity is 0. That means, so if you consider this is the Earth, at the center of the Earth, the value of G is 0. At the surface of the Earth, the value of G is 9.8 meter per second square. As we move higher to the surface of the Earth, the value of G decreases. Even though if you move deep inside the surface of the Earth, then also the value of G decreases. And always remember that on the surface of the Earth, it is considered as 9.8 meter per second square. But this value changes at different places. That means on Sun, the value of G is different. On Moon, it is different. On different planets, the value of acceleration due to gravity will be different. Now, let us try to understand in detail regarding that capital G, that is universal gravitational constant. So, what is universal gravitational constant, children? The force of gravity, universal gravitational constant is the force of gravity which is depends upon, which is the product of unit masses. So this force must be acting between two bodies, which is the product of masses, unit masses, as well as square of the distance separated by. So in order to explain you clearly, children, force is equals to G M1 M2 by R square. If M1 is equals to M2, each is equals to 1 unit, whether it is 1 kg, 1 gram, whatever it is. So 1 unit I'll be considering. And the value of R is also 1 meter, 1 centimeter. If taken in SI system means it should be in kgs, it should be in meters. If taken in CGS system means this is measured in grams, this is measured in centimeters. So depending on the system of units you'll be considering, those values must be 1. If you substitute M1 as 1, M2 as 1 and R1, R square as also 1, R as 1, then the value of F is equals to G. So how do you define universal gravitational constant? It is defined as the force due to gravity acting between two bodies of unit masses separated by a unit distance. I repeat, universal gravitational constant is the force acting between two bodies of masses, of unit masses separated by a unit distance. And as I told you that the value of acceleration due to gravity is 9.8 meter per second square, the value of universal gravitational constant will be 6.67 into 10 power minus 11 Newton meter square per kg square. So what is the value of acceleration, universal gravitational constant? 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, so even though we move higher to the surface of the Earth or deep inside the surface of the Earth, the value of G changes, decreases. But the value of capital G, that is universal gravitational constant, remains constant even though you go higher above the surface of the earth or deep inside the surface of the earth, this value remains constant. This value, acceleration due to gravity at the center of the earth, is taken as 0. But here, capital G is always constant, whether it is at the center of the earth, the surface of the earth, or away from the surface of the earth. Whatever the place you consider, its value remains constant. Its value, whether it is sun, planet, moon, wherever you consider, the value always remains constant, will not change from place to place. So this is all about the differences between the acceleration due to gravity and universal gravitational constant. If you want me to write down, so go through this, children. Acceleration due to gravity, indicated with the letter G. This is your universal gravitational constant, indicated with the letter capital G. Okay, so what is your first point? The acceleration produced in a body which is falling freely due to gravitational pull of earth, due to gravitational pull of earth. What is universal gravitational constant? It is the force of gravity acting between two bodies of unit masses separated by unit distance, separated by unit distance. Now, look at the second point, children. As we move higher above the surface of the earth, or if we move deep inside the surface of the earth, its value, the value of G decreases. The value of G decreases. But this value, whether you move higher above the surface of the earth or though you move deep inside the surface of the earth, its value remains constant. And how much is the value, children? So this value will be the value of G on the surface of the earth. The value of G on the surface of the earth is 9.8 meter per second square. Whereas the value of G remains constant anywhere in the universe and its value is 6.673 into 10 power minus 11 Newton meter square per kg square. Whether you take, if you take this value at the center of the earth, at the center of the earth, the value of G is 0. But here at the center of the earth, its value, whether it is center or anywhere, its value will never be 0. Always constant, that is 6.67 into 10 power minus 11 Newton meter square per kg square. Anywhere in the universe you can say it will never be 0. But at the center of the earth, its value will be 0. Whether you consider, if you consider the value of G on sun, it will be different. On earth, its value is different. On different planets, its value will be different. It's on moon, its value will be different. So different places, the value of G will be different. But what about this, children? It will never change. It is constant whether you consider on the surface of the sun, moon, earth, any other planets, wherever you consider, the value of G will not change. So this value remains constant. So this is all about your differences between the acceleration due to gravity as well as the universal gravitational constant. Okay, children.